Afternoon all. Quick video just to go over what we did last lesson. Seemed quite far away now, so we'll go through a few examples. Normal distribution, you might have missed the lesson, so going to be a quick catch up for you. Make sure you know what you're doing, and then I'll give you some work to do over the next few weeks. So what I would do here, just pause the video, work through this example. It's quite quick, and just see if you remember what you need to do, to be honest. Okay, so going through it again, we've got x, so there's no context to this question, we've just got x distributed normally. Now the 12, remember, is the mean. Okay, so mean in my best writing. Now the 2 squared, now the reason we write it like that is the standard deviation is 2. Okay, so sigma is 2. Right, standard deviation, but this is the variance, right? So variance is 4. Okay, so variance sigma squared, just put with alpha now, is 4. Okay, so remember when we do this, this is the mean, and then we've got variance, so mean and variance. Okay, and we want to work out a probability of this x, random variable x, being between 10 and 13 inclusive. Remember me saying it doesn't matter if it's inclusive or not. Alright, so to calculate these, easiest way, using your calculator, using the normal CDF function. Remember, we don't do normal PDF. It'll ask you for 4 things, and I want you to be writing these down. These are your exam marks coming through. So you should have had the means 12. The sigma is 2, okay, because it's standard deviation. So don't just assume it's whatever's in here. Alright, it needs to be standard deviation. The lower limit is 10 and the upper limit is 13. Plug that into your calculator, should come out as 0.5328. With B, we want random variable x to be greater than 6. So again, normal CDF, same values for mu and sigma. It's just the lower and upper now. We're going from 6, so I want the random variable x to be 6 or greater, and that doesn't have an end, but I can't do infinity on the calculator, so I just put a very big number in, okay, to represent that infinity. Doing that should come out as 9987 if all is good. So we'll do the same again. Next question, have a pause of this video and do what you can, and then we'll go through it. Alright, so let's decipher what we've got first. We've got a mean of 250 grams and a variance of 20. Now it says grams squared. That's just because the way formula for variance works, we're squaring the units. The variance is just 20, okay, not 20 squared or anything like that. So instantly, I want to be writing x is distributed normally, 250 mean, and 20. We've got to remember this is variance, alright? Find the probability the randomly selected customer buys a standard will receive more than 255 grams. So here's my notation. Going into the calculator now, the only important bit to note, we've got the mu is 250. The standard deviation needs to be root 20. Okay, the variance is 20. So standard deviation is root 20. Lower limit 255. And this is going upwards to infinity, so up at 99999. Answer should come out 0.1318. Okay, next. Sample of 180 customers, each one buying a standard container. Estimate how many would expect to complain. Right at the start, they would complain if they received less than 240 grams. Okay, going right to the start, 240 grams if they complain. So, first thing I want to ask myself, what's the probability of a single person, a single customer, getting one that is less than 240? Normal CDF again. And this time we're going 240 downwards. Okay, so visualize it, 240, and we're going downwards, and that goes to negative infinity. So I need this minus 99999. Should come out as 0.0127. Then, you know, think of that as being a 1.27% chance of a customer getting a less than 240 grams of popcorn. Well, if I've got 180 customers, 1.2% of them should not be happy, and they'll complain. Okay, so multiply them together, we get 2.286 customers expected. You know, so between 2 and 3 customers each time. All right. Good. Next example. So I've gone from example 2 to example 4. Good maths, that. Pause this, have a go, work through it. Bit tricky last question here, and especially B as well, actually. But have a go. Okay, so reading through it, we have a mean. Okay, so fish caught by a trawler, going to have an average weight of 4 kilograms. It's going to have a standard deviation of 0.5 kilograms. And it's called a juvenile if it's less than 3 kilograms. So instantly, like before, X is distribute, X being the weight of a fish, distribute normally, mean 4. And notice how I'm writing it this time, right? It's a standard deviation that they've given me, so I've gone 0.5 squared, because this is actually variance, but I can easily see that the standard deviation there is 0.5. Okay, probably helps. So A, what is probability of having a juvenile fish? Well, juvenile is less than 3 kilograms. Into my calculator, mu is 4, standard deviation is 1/2, low is negative infinity or minus 99999, and the upper of 3. That should come out as 0.228. B, if 300 fish are caught, what's the probability that there are more than 10 juveniles? Right. Nice little twist to the questions. Okay, bringing up something from AS level. We can have 300 fish are caught. So that's a fixed number of trials. And I want to know whether there are more than 10 of these. Now what I know from previously is I know the probability of one of these fish being juvenile is this 0.228. So that's a probability of one event, one fish, one event being juvenile, and I want to work out probability of more than 10. So what we've got here is a binomial with a sample size of 300 and the probability of a single fish being juvenile is 0.0228. Now it's asking for assumptions and validity. We're sort of assuming that each of these fish are independent from each other. If I've got one that is juvenile, is there a bigger chance or a lesser chance that another one of these 300 are going to be juvenile? Probably, So actually, this probability probably isn't fixed and the events probably aren't independent, but we're assuming it just so we can calculate it. Okay, so they're just looking for your reasoning in these type of questions, and you might be able to go either way on your answer. But moving on, so what we want to do is work out probability of X being more than 10. Now remember from AS, we need to have less than or equal to in order to use our calculator. So greater than 10 is the same as 1 minus less than or equal to 10. Okay, the opposite of this, this here is the opposite of this here. I'm doing binomial CDF, right? This works out less than or equal to on our calculator. N is 300, P is that, and X is the 10. Those are the figures and should end up as being 0.0851. Okay, so it's a nice way of mixing in a bit of binomial with a bit of normal. And C is a bit nice as well, so I'll go to an extra screen. So here, we've got a given that a fish is a juvenile. What's the probability as a mass more than 2.5? So here, the interesting part is the given that. Right, we need to twig given that. I know something extra. I've got this extra piece of information, so it changes the probabilities. And my notation, sorry, that's just from earlier. My notation is this: the probability. Right, I want to work out the probability that the mass is more than 2.5. Think of this line as being given that. I know it's a juvenile. A juvenile was if it was less than 3. Okay, so this is the juvenile bit. And this is what I'm working out. Think in my formula. The top of the formula for this is these two combined. So that means I want to be greater than 2.5 and less than 3, which is where I've got this from. On the bottom, it is just what I am given, which is this. Okay, so I know, it's limited. This formula is telling me, well, I know I'm down to these juveniles. How many of them are between 2.5 and 3? So here, we've got this one from earlier, we worked out in part A, and work the top one out, normal CDF, 4, a half, lower 2.5, upper 3, and it should come out as 0.0214. And the final answer, 0.9386. So again, another way that they can just make a normal distribution slightly harder by combining it with a bit of conditional probability. So what I'll do is I'll release questions for you to do, try them, work through them. Once you're done with it, take a photo, send them in, and I'll see how you get on with it. Thanks, have a good day.